Now let's move on to Ethereum. So Ethereum is one of the most important concepts that showed up in blockchain in the last few years, maybe the most important in the last few years. The idea behind Ethereum was to create a decentralized computer. A computer should do things such as perform calculations, store data, and allow communications. So Ethereum proved that by using a blockchain, you can execute what's called smart contracts, which are Turing complete. So you can use a blockchain not just to exchange coins with each other. You can use blockchain to do anything you want. You can have a smart contract with arbitrary conditions in it that trigger other contracts and other conditions in the network, effectively creating a real virtual computer. The currency of Ethereum is called Ether, and the main programming language is Solidity. So Ethereum is currently using proof of work. However, it's going to move on to proof of stake, which proof of stake is a different mechanism where the nodes are asked to stake some parts of their currency, and then once they do this, they can verify transactions. If they do something wrong, if they fail to verify a transaction, or if they lie, then they lose some of the coins they've staked. So why Ethereum is so important is because it allowed the creation of initial coin offerings through the use of smart contracts. Initial coin offerings raised billions of dollars over the last couple of years. And the reason that ICOs exist is partly because of Ethereum, of this amazing technology. And this innovation, this discovery that we can have Turing complete transactions on a blockchain. Another interesting distributed ledger is Corda. Okay, Corda is developed by the R3 consortium. And Corda is not really a blockchain, it's a project that's blockchain inspired. It's a distributed ledger, but it's not a blockchain. And if you ask me personally, I believe that this kind of ledgers are the future because blockchains are very costly to store after a point. So Corda is focused more on financial applications and in applications where there needs to be some kind of agreement between different parties as to the state of the ledger. However, there needs to be privacy. That is, not everyone needs to know all transactions, and they shouldn't. So Corda allows verification of transactions only by the parties that are actually participating in this transaction and follows a pluggable architecture. So there are different kinds of algorithms that can be used for consensus or for other parts. Then we have Ripple. Ripple is a blockchain solution for global payments. It's a payment network, and its main focus is in creating a very fast and cheap payment solution. So it's an open source protocol, however, it's not a completely open in the sense that anyone can join. It's run by a company, it's not completely decentralized. And the consensus works through a set of independent validator nodes. Ripple has its own unique consensus mechanism, but these validator nodes, again, it's not an open invitation. You have to apply to join the network. So Ripple recommends to its clients that they use trusted nodes in order to verify transactions, and each client has what they call a unique node list. And when transactions go through, then these nodes in the unique node list, they try to reach consensus as to what the true state of the ledger is. Again, the key here is that these nodes are special nodes. They're not just, it's not an open network. So these are nodes that can be trusted. And there's a majority voting mechanism in place in case that it's difficult to basically reach consensus voting. The nodes do not have to agree necessarily on 100% of the cases. So Ripple's big bet is that it can provide a very easy way to make transactions between borders. Again, Ripple is really focused in financial applications. So here I have some numbers for comparison. Bitcoin can do 7 transactions per second, Ethereum 150, and Ripple 1500. From Ripple, we go to Stellar. So Stellar was created more or less as a spin-off of Ripple because the person who started Stellar was in Ripple before that. And again, Stellar has a focus on finance and money transfer. However, it takes a different approach. First of all, it has its own consensus algorithm, and consensus is reached every 2 to 5 seconds. This algorithm is called Federated Byzantine Agreement. And in contrast to Ripple, membership is completely open, control is completely decentralized. The coin of Stellar is called Lumens. So the Stellar consensus protocol is very special. Again, Stellar is not a blockchain. The key difference between their algorithm and other algorithms is that each node that wants to be part of the network chooses other nodes whom they trust. And this group of nodes is called a quorum. So quorums, as you can see in this image here, they overlap with each other. And then there's a process and a proof around this that eventually nodes will reach consensus around the true state of the ledger. And you can see here comparison between Stellar and Ethereum. You can see that Stellar is faster, also much cheaper, and can do more transactions per second than Ethereum. So you can see that for financial applications, it is much better. Stellar has also a very interesting tokenomics mechanism. It has an inbuilt inflation mechanism. So new lumens, new coins are added to the network at the rate of 1% each year. This means that the network will never run out of lumens. And then these are distributed to nodes in the network based on their voting power, where voting power again is determined by how many lumens you hold. There's also the potential to join pools where you aggregate all your lumens together and then you get rewarded with more lumens. So Stellar and Ripple might seem like they're trying to solve the same problem, but they have a different business focus. So Stellar is mostly focused on providing greater access to finance to the world's unbacked population and promote financial inclusion. On the other hand, Ripple is a for-profit company and is mostly focused on payments with large financial institutions. Finally, Lumens has different tokenomics, Stellar has different tokenomics. New Lumens are created at 1% every year, whereas Ripple is destroyed with every transaction. So in theory, Ripple will run out eventually, even if this takes hundreds of years, because this coin can be subdivided. So this is basically an argument around sustainability. I mean, it's clear that Lumens is looking at a more sustainable and more beneficial for the society solution. Now we move on to NEO. NEO is a very interesting project, and it's also called the Ethereum of China. Why? Well, because it's pretty similar to Ethereum in some of the things it tries to do, and it's backed by the Chinese government and is super popular in China. NEO has very interesting tokenomics because it's a rarity in the sense that there are two tokens in the NEO blockchain. The one token is called NEO and the other one is called gas. So NEO tokens represent ownership of NEO. And they can be used to create blocks, manage the network, and when you hold NEO, you get rewarded with gas, and gas is what you need to actually run things on the network, much like Ether. When you run a smart contract on Ethereum, you need to spend Ether, well, you need to use gas for NEO. So it uses an algorithm called Delegated Byzantine Fault Tolerance. And there are also some other NEO-related projects. We have the NEO contracts, which can be executed in languages such as C# and F# and Java, which makes it easier for most developers since they don't need to learn a new language like Solidity. Then there's the NEO file storage, NEOFS, and there's also NEOQ, which is a mechanism that ensures that NEO is quantum proof in terms of its security and encryption. So delegated Byzantine fault tolerance. So delegated Byzantine fault tolerance works according to this principle. You have participants in the system, and these participants, they choose other nodes as bookkeepers, and then these nodes that have been chosen are responsible for reaching a consensus. These nodes have some voting power, which must not be equally shared, and they must be maintaining a minimum balance of NEO and meet certain performance requirements. So there needs to be a 2/3 majority for adding new blocks to the blockchain. If consensus fails, then an alternate bookkeeper is called. So NEO claims to be able to validate 1,000 transactions per second, and they're planning to do this to up to 10,000 transactions. However, the issue is more centralization. That's the issue behind NEO. And indeed, there might be only a few nodes that validate transactions, and it's clear that even if there's more centralization, NEO might not have as its goal to be completely decentralized. This might also be related to the fact that it's backed by the Chinese government. A project that I'm particularly like is Hyperledger Fabric. So Hyperledger is an open source system created by the Linux Foundation and backed by IBM. It's a permissioned blockchain system, and it has enterprise focus. It's very pluggable, which means that you can define different consensus mechanisms and different ways to set it up. So why someone would want to do this? Well, if you're a big enterprise, you can use Hyperledger Fabric to set rules as to how different departments should communicate with each other, and at the same time, record all transactions, all kinds of information on the blockchain. You could even have multiple enterprises coming together and defining different rules between departments that each enterprise possesses. And there's also the possibility of running smart contracts, which in Hyperledger Fabric is called chain code. It's a very flexible project, and there are many use cases of Hyperledger Fabric. I mean, it's really worth of a video on its own to just even try and cover some of the possible use cases that Fabric could cover. And another favorite of mine is IPFS. So IPFS stands for the Interplanetary File System, and it's basically a combination of GitHub and blockchain. So IPFS keeps pointers to files and changes on the blockchain, but those files are not stored in a central repository. They're stored in people's computers. So you can ask for any kind of data you want on IPFS, and you don't have to go through a central server. So the big vision behind IPFS is that it could replace the internet and the current internet structure where there are central servers and these servers are serving the pages. Where instead of this, there could be a peer-to-peer network and the fastest node responds back with the latest version of a page. Again, IPFS is very exciting, and besides trying to revolutionize the internet, it can also be used as a blockchain alternative to services such as Dropbox and Google Drive. There are many consensus algorithms. We're not going to cover all of the different kinds of consensus algorithms here. We're just going through an overview that we can see on this very nice slide. So we started with proof of work, and then we have proof of stake, which Ethereum is going to transition to that, and delegated proof of stake, where you have nodes that delegate the responsibility to other nodes to reach consensus, and then least proof of stake, proof of elapsed time, different kinds of Byzantine fault tolerance. I mean, there are many algorithms out there. Whereas proof of work was what started the whole blockchain revolution, it was soon proven that it's a very expensive algorithm, it causes harm to the environment, and it's not completely secure. So all these different consensus algorithms have been created in order to try and solve issues such as efficiency, the number of transactions that can be processed per second, scalability, etc. I'm sure that we're going to be seeing more of these coming out over the next few years. And the question that you need to ask yourself if you're interested in this area, if you're planning to use a blockchain for whatever reason, to run an ICO, to create a new business, you need to ask, which blockchain is for me? In this video, we saw some different types of blockchains and a few things about the history of blockchain, but there's so many more projects out there. There are different kinds of blockchain, different kinds of decentralized apps. It's a very exciting time to be involved in this area. However, it's also difficult for someone to make the right choice. And this is where the Tesseract Academy can help you. This is where some education around these topics, around blockchain, around data science, around deep technical topics can help you make the best decision for your business. This was Stelios from the Tesseract Academy. I hope you enjoyed this video, and I hope that you're going to also watch some other of our videos where we cover topics such as other types of blockchain, deep learning, data science, and optimization. Topics that are of great interest to the modern decision maker who does not want to be left behind in this battle of modern technology. Thank you. Have a good day.